just before we start, just guys, if you have any questions, please type them in the chat. I will be happy to respond to all of them, sometimes during the presentation itself, sometimes after the presentation. Please do not interrupt me without like a critical need, but we will have some time dedicated for a small chat and to answering the questions. So let's start with the agenda for today. We will start with the introduction. We will talk about the diffusion models, which is like essential need for visual generative AI. We will talk about Stable Diffusion itself, about its technical capabilities, like current use cases, challenges, and as well, we will talk about some modern or hype topics and practical setup, what you need to develop some use cases or even like create your own startups with visual generative AI. And we will talk slightly about market overview. I prepared a very large presentation, and we can skip section about me, or I can introduce myself very shortly. So right now I work at SoftServe R&D. We have a lot of visual generative AI projects. Previously, I worked with the classical computer vision, with machine learning, with data science in general, but mostly in computer vision domain. But just like 1-2 years ago, I switched to the visual generative AI, mostly working with Stable Diffusion. I wrote my master's thesis at Oxford about Stable Diffusion and its applications. And right now, within my company, we have different projects with different domains, which go beyond just utilizing existing models from diffusers or from Hugging Face. We are actually building the pipelines and solving like a real life challenges for like a top companies. And we will talk about it slightly today. But the question from my side is, who are you guys? You can type in the chat, are you a technical or more business-oriented people? Because my presentation is full of technical stuff, but as well, I want to touch some business use cases, and it will be better for you and for me to structure it in the best possible way when you will just type if you're technical, business-oriented, or something like this. Just for me to understand how to provide the information in the best possible way. Okay. Okay, got it. So we have some people, actually it's like 50-50, I guess. So, okay, we will talk slightly about technical stuff and slightly about business-related stuff. And let's proceed. So another question as well, you can answer in the chat. What is GenAI? Let's wait for a few answers and we will proceed. During the presentation, I will sometimes ask you a few questions just not to keep you bored and to have some interaction between us. Yeah, let's wait like 20-30 seconds. Yeah. Nice answer. Okay, okay, that's great because we have hallucination. It's a great answer for this question. That generate stuff is as well very good answer because right now a lot of people, especially salespeople, they're considering GenAI as only LLMs. So for them, GenAI is equal to LLMs, but that's not true. There are a lot of visual applications of GenAI. And sometimes there are no so much low-hanging fruits, but still there are a lot of opportunities, and they're raising with, especially with multimodal LLMs and different models from OpenAI like Sora, etc. We'll touch this in today's presentation. So, okay, let's start with the introduction. Definition of generative AI. So we had some of your responses, and they were correct, because we can consider generative model as the model that can generate some stuff, not necessary textual data. But let's have a clear definition of generative AI. It's a type of AI that allows machine to create new content based on patterns they've learned. Why it's important? Because sometimes the patterns might be developed from textual data, from image, video, different guidance, but sometimes it can be just like noise or nothing. It can be a random generative model, and actually we can generate different modality data, and we can have inputs and outputs of any modality you want. Here, just a slide that GenAI and LLMs are different stuff. So here we have just a simple diagram of AI, machine learning, neural network. Sometimes in universities, lecturers are providing these diagrams to understand the difference between machine learning, neural networks. So let's clearly define this, that LLMs and visual GenAI is different stuff. Sometimes they can be combined in multimodal way, but let's consider them different stuff. Let's start with a brief history. Everything started with the origins. We can consider, it's my personal subjective opinion, but it might be interesting for you. So everything started in 50s, and we can consider the first stage of generative AI advancement between 50s and 90s, where the first AI models like perceptron, etc., were released. And the important step here was 1998, when Jan LeCun presented convolutional neural networks. Okay, I believe that the majority of you are aware of this. Then, from 90s till now, we can consider autoencoders. Why is that important? Because those were the important critical models actually for generating visual content. Visual content is hard to achieve because it's very high dimensional content. And those autoencoders presented the way how to encode the data and how to operate with such a complexity in an optimal way. And for example, in 2019, the VQ variational autoencoder 2 was presented, and we were able to achieve a generation of like all of those deep fakes, and there were a lot of websites where you should guess if the image is generated or not, something like this. And from 2014 till now, we can consider the era of generative adversarial networks proposed by Jan Goodfellow. As well, it had some parity with autoencoders, but GANs were widely used, and as well, different companies like NVIDIA introduced models to generate like high quality images at that moment, like some people faces, something like this. So it was an important step. But now to the more interesting stuff. So in 2021, Stable Diffusion was presented, and it's a stage where we now. So in 2021, original paper was proposed. In 2022, people started using commercial models. So how it works, like you're developing some research, it's a hard work to do, you open source it, and after that some great minds, great business people think how to commercialize this stuff, and that's how it was. We know DALL-E case and Midjourney case. And the important step for me was in 2023, the introduction of ControlNet, where you can actually have a control over the generated image. And in that case, you can explore more use cases, and the generative content becomes more applicable to the business. And next steps, it's where are we now? And as well, here someone mentioned hallucinations. So there are a lot of problems still, and we need to resolve them, and we need to optimize a lot of stuff for the models to become better and better every time. Okay, so let's proceed with Stable Diffusion. It's just an introductory slide. So how it works, we have a prompt, for example, teddy bears in the futuristic clothes, watching great presentation about generative AI. Let's consider Stable Diffusion a black box for now. And as a result, we receive the image of what we actually described in the prompt. But the idea is of this power of personalization, because if you want a different image, you just change the prompt. For example, today we have a larger audience, so let's add like large stage, larger audience. Or, for example, we want a round table and we want more like a cartoonish style of the generated image. Not a problem at all. We can do this based on the power of Stable Diffusion. And now we are going to the section of how actually diffusion model works, more from the technical stuff. I will try to explain it on the high level, how I explain it to my non-technical wife, but if you want to dive deep more, we can discuss it. Just let me know in the chat. I will monitor it. I just want you to be interested in the presentation, not to get bored. So let's proceed actually. Okay, so we are starting with some theory, with the diffusion. So in physics, the diffusion process is the movement of, for example, atoms, molecules, energy from a region of higher concentration to a region of lower concentration. Here are some nice visualizations of it. For example, if you drop an ink to the water, it will spread out, and you won't be able to tell what was the original drop point of the ink. And that's not that important for us, but the main concept is that you won't be able to tell what was the original drop point. And that's why actually we have this as well process in GenAI called forward diffusion. Because forward diffusion is a process of gradually adding a noise to the image. For example, this is my image like 4 years ago. And with this forward diffusion, we add just a random noise. Let's consider random noise. And after first step, we can still identify myself. After second step, still more or less clear that it was me originally. But after like step number N, we won't be able to tell what was the original picture. So, and we cannot tell if it was like Taras or Anna or someone else. So that's why this is like intuitive way why it's called diffusion, because we cannot identify the original drop point, and here we cannot identify the original image. We can see noise in the end. And this is how it works. So when it was not the problem when we are operating only my image, but for example, if we have a few images of myself and a few images of a cat, for example, we want to train, for example, some model. And with the forward diffusion, both me and both cat will become noise eventually. And after that, we won't be able to tell if it's noise or if it was me or the cat. But it gets more interesting with the process of reverse diffusion. Reverse diffusion is actually how we can go from the random noise to the original image of myself. It might be not identical to the image provided here, but still we want to get me in the process of this reverse diffusion. So here is just a high-level pipeline. We generate a random noise for the image. We corrupt the image by adding noise to a certain number of steps. That was discussed in the forward diffusion. Then The critical point is noise predictor. Noise predictor is a special, we can call it subnetwork, that learns how much noise was added to the original image. So on each step, we can like train the noise predictor in such a way that it will know how much noise was added and what was the nature of that noise. And with that case, when we taught our noise predictor, as a start, we can generate a random noise, just a noisy image. But the idea of that is we can ask our taught noise predictor to generate the noise that like it thinks it was added, and we can subtract that noise on each sampling step from the noisy image. So in that case, we are subtracting specifically constructed predicted noise by the noise predictor from the original noisy image. And with this step of backward diffusion, we are getting my image step after step. If you played with Stable Diffusion previously, you may refer to like DDIM sampler or something like this, or when there is a process of generation, you have multiple generation steps. For example, in classical Stable Diffusion, like 50 or 25 of them. So on each of that 25 steps, the noise is subtracted from the noisy image in order to get the final smooth image as a result. Now let's talk about latent models. So what I taught, what I just mentioned is ideal, but only in imaginary world. It doesn't work so perfectly because of the high resolution of the images. So, for example, let's consider like image of resolution 512 by 512 and 3 channels RGB. So there are like almost 800,000 values, and to operate like with this space, it's very computationally expensive. That's why we need to compress the image. And here, remember we mentioned like 2 slides of a history, and I mentioned variational autoencoder. So the idea is that we have an encoder-decoder architecture. We start with my image, with, for example, a lot of my images. And encoder learns how to encode my image to a small representative vector. We call it like latent space. So that decoder can decode that original encoded vector to the original image. The idea is that, so we start with like almost 800,000 values, and we can select the dimension of latent space to be like, I don't know, like 100 or 1,000 values. And this vector will be representative of our image. And with that idea, we can operate in this latent space. And the idea of Stable Diffusion is to utilize that latent space. So to generate something, all models need to learn for a lot of steps. Stable Diffusion was trained on millions of the images, and we need to train the model for like a serious amount of time in order to learn something. Here is just like high-level visualization. So on how the training of Stable Diffusion was done. So we start with a prompt cat, and we also provide some image of the cat. And during the inference after the first iteration of training, it still generated a noise because noise predictor haven't seen all of the enough images to learn how to subtract that noise. After iteration 100, for example, those are real experiments, by the way, we started seeing something more or less similar to the cat. And after like 10,000 iterations, we can see a cute cat, like high quality image. Here it's just a general slide. I guess the question, let's, instead of going through that slide, the question to you, have you trained Stable Diffusion? Please respond to the chat.
Yes, little bit.
Okay. Okay, there is a question for Stable Diffusion for commercial use, yes, but there are some problems. We will mention them later. Just a fun fact about training Stable Diffusion. So right now there is a Stable Diffusion Excel that is widely used. There is no official training code from Stability AI to train Stable Diffusion Excel. There's only fine-tuning code. And that's a problem. That's a problem for a lot of businesses, a lot of startups that want to use Stable Diffusion, and we will talk about it later. We will talk about training rather than fine-tuning. Okay, now let's come back to the latent Stable Diffusion. So we mentioned like just the diffusion model when we have forward diffusion, when we are graduating noise, and backward diffusion when we are getting back the nice image from the noise. So the idea of Stable Diffusion is just to use the same operations, but not on the original images, but to use them in the latent space. So in that case, we will be able to save a lot of computations. So for example, when we start with the cat, we use encoder. We encode the cat in like a vector of 100 values. We then teach noise predictor on those small vectors in this latent space, and then do the reverse process and decode the image. And in that case, we receive the generated image of a cat. It's saving memory, it's saving computation, and it's the only way to achieve such results. And but actually, so we were talking about images like this forward backward diffusion, but we know that we are operating with prompts. And here, the high-level description of how the text embedding works within the Stable Diffusion architecture. So we start with a text prompt, for example, a photo of a cat. After that, there is a tokenizer. So the tokenizer is needed to transform the words from the human language into some computer readable format. So for example, we have tokens like, it's just the numbers, like 50, 24, something like this. After that, we have the embedding layer. Tokenizer is still just different numbers, but the prompt can be of a different size, and the number of tokens will be of the same size as the number of words in the prompt. But why we need embedding is actually to have a representation of the whole prompt itself, a unified representation. For example, if you entered like just the word cat, or if you describe a whole story about the cat with like 1,000 words, embedding will be a unified vector in Stable Diffusion architecture. It will have 768 values in order to then be processed by text transformer. So text transformer is another subnetwork that is able to transform that vector within some layers, like linear layers or attention layers. It doesn't matter for now, to get this representation of the original text to the noise predictor. So noise predictor actually learns on the original image plus this vector from the text transformer. And here there are different options what you can use. So you can use like T5 clip or some other embeddings. But the idea is that noise predictor should get the vector representation of the original text prompt in order to proceed normally with the image generation. So here is the modified version of the image that you saw already. Here as well, forward and reverse or backward diffusion, but we have the image description and text encoder. And the same we have during training, we have it as well for the decoder, because noise predictor learns on both of the ways. So here are just a small modification to add the additional information to the noise predictor on each step of forward and backward diffusion. If something is unclear as well, feel free to ask questions in the chat. Actually, here it's just like the summarization of this text to image. So this textual prompt is a way to control the generation, because actually you can generate something without a textual prompt. But if you want to receive the specific object, it's the only way for now with classical Stable Diffusion to receive the result of a cat, for example. But let's talk about something more interesting, image-to-image models. And this opens for us like much more use cases. For example, if you want to, there are a lot of like startups use cases when, for example, people are generating LinkedIn avatars or avatars for games, or they want to change their interior design. Those are all image-to-image applications. For example, here we can use text prompt as a guidance and input image. Here, as you can see, we have some sketch of a cat. Sorry, I'm not the best artist, but I hope it reminds you a cat. The idea is that, as you remember, we encoded text prompt in an embedding and in a vector space. The same is done with the image. So we have some alternative input image encoder. So the image as well is represented initially as a matrix and then as a vector with some learned features. We just combine the text prompt and input image and use this as a guidance, as another input for the noise predictor during this reverse diffusion process. Thank you. Okay, so let's proceed. The concept that was described on the previous slide was actually a concept presented in ControlNet. That's why I'm a huge fan of it, and that's why I highlighted in the history of visual generative AI. The idea that it adds not a textual conditioning, but as well spatial conditioning control to the image generation. And here are just a few examples on how it's done. For example, here is a sketch of a turtle, and it generates like this. And the idea is that you can generate the image even without a textual prompt. You can just use this spatial conditioning, and it will generate some result by understanding that it's a turtle. Here we have a human pose, and it can randomly generate any human in any pose. But for example, if we type astronaut in the text prompt, it will generate astronaut. As well with segmentation, with depths. And that's a critical slide, because I cannot disclose like the project, the specific projects that I'm working on, but there are a lot use cases, a lot of projects where we use this ControlNet and different variants of conditioning. For example, from construction to printing services to manufacturing, as well to some marketing content generation with this, for example, depth guidance or edges, or because it's a way for you to control what you actually want to see on the image. We will talk about it later as well. As well, we mentioned ControlNet is only one extension for Stable Diffusion, but there are much more. So in order to control it, we have control net, image to image, like different modalities and style transfer, and it's evolving every day. Every day there are a few more new papers, and there is no time actually to read all of them. For fine-tuning, we have specific data sets available. I will mention the resources for you. We have different fixing problems with fine-tuning, like specific, like for example, 6 fingers or something like this. There are a lot of ways developing in the efficiency of generation or training, etc. Like Loris, it's for training, efficient inference, efficient training, TinySD. This is all is needed for the business because each, for example, API call for the model is some money. So, for example, if the processing time is 20 seconds, you pay like 9 cents. If the processing time is 10 seconds, you will pay 5 cents. So you're just saving business money while getting the same result. And there are as well like different extensions for vector graphics. For example, if you want to have a project for printing companies where the high resolution, like infinitely high resolution is needed, it's a great usage. For 3D generation, like different painting, outpainting, high resolution techniques, etc. If you have questions, I will be glad to discuss everything. Let's now talk about the technical capabilities of Stable Diffusion and similar models. So the first very common popular use case is to denoise image and to add like super resolution or something like this. This can be done as a feature for a lot of image processing tools or on your like mobile phones, or it can be done even for Adobe Photoshop or something like this. And it's a great use case, but it's more or less simple and right now very common use case. Everyone does it, but that's a great technology, for example, to restore like low resolution or old photos or recolor black and white photos or something like this. In painting, outpainting, it's as well very common capability of Stable Diffusion, but it has potential in different use cases. For example, how to explain it, we have the original image of the dog sitting on a bench, and we want to replace a dog by a cat. We just select the dog, we type prompt cat sitting on a bench, and with this extension, we can replace dog by the cat. And outpainting is when we, for example, start, I imagine that this is the original image, we start with the cat, and we want to add bench in a field, and it will extend the original image for this. While it may sound easy and just for fun, it actually has a lot of business use cases. The first one is in marketing, customization. For example, you have some religious or even regulatory differences in different countries. For example, imagine you're advertising something. You're advertising like spirits or tobacco around the world, but you want to extend your business to Middle East. You cannot have advertisement of tobacco on some, for example, like cars or other advertisement methods on the car. So you can use in painting just to remove some objects or replace them. Or, for example, another use case is when you're a toy company and you want to create a marketing material where the kid is playing with some toys. So you can have one photo shoot of a kid, or even you can generate a kid from scratch, and you can just replace toys just for different marketing needs, something like this. As well, if you will have questions, we can discuss it more in more details. Style transfer, common use case. For example, if you want to create your image in the style of Disney princess, I don't know, or like Star Wars character, it's easy to do so. but the majority of those use cases are actually really for fun. But style transfer actually has a lot of serious applications. The first one, for example, I was working on the project with seismic data. When you were working with images provided by one company for seismic data, and after that, another vendor is providing different images for seismic data. Their distribution is different, and you can apply actual style transfer with the power of generative AI to learn this mapping between those distributions, etc. Or there were some other use cases, for example, even in the case of military actions or cases for drones, where you want to apply the style transfer for different distributions of cameras from different footage or from day and night footage, etc., etc. Video generation. I didn't want to touch this topic too much, but I know that there is a lot of hype around this topic, so let's discuss it for a bit. So what's the first way to generate videos? Is to actually create a sequence of photos. And with ControlNet, for example, you can create like sketches and shapes of the cats and generate multiple frames and then connect it to one video. But the problem is consistency. And here you can see that we started from one cat and each a completely different cat. And that's not okay for the business needs. But after that, there were extensions like Stable Video, or here is it's not Stable Video Diffusion, it's a Stable Video extension, where you could change some characteristics or change some parts of the object on the existing original video. So it was not text to video, it was text plus video to video. So for example, you can change colors, you could change sunset. It was easier to keep consistency because of the shape, etc. But after that, the Stable Video Diffusion as well from Stability AI was presented. And actually, the main idea of this model of their paper is that they achieved the consistency for frames generation, because the next frame is conditioned not only on the text, there is a time and spatial conditioning as well, and the next frame is as well conditioned on the previous frame. And what's interesting about this is, for example, let's consider this left bottom video. We can have like a rotation of the camera, and potentially we can have like 360 rotation of the camera. If you have 360 video, you can then apply Nerve or some other tools to create a 3D models out of it. So generation of high quality consistent video potentially means that we will be able to achieve a perfect generation of 3D models. And about Sora, I added one or two slides about Sora because it's very hyped, but I don't want to dive deep into Sora because it's not released. They have a technical report, but still it's very limited. But still, the images are really perfect. They are perfect in a lot of senses, from the shape, from consistency, and the important from the rendering quality, because you can see all of those reflections on the water, etc. And it's really hard to achieve. And Sora did it, as OpenAI claims. But the problem with Sora is probably that we don't know what was the training data set for it. And if the IP rights were properly agreed, and there was an interview of their CTO, and she avoided answering that question. So she mentioned that videos are from the public domain, but not all of the images from the public domain or videos can be used to train neural networks. But just to give you a few key features, technical features, how it works. So the first one is utilization of visual patches as tokens. Previously we had tokens, and I mentioned tokenizer for text. Here, visual patches, like just like some small patches of image, are represented as tokens. They have a separate compression network, as well as I mentioned previously, like the high dimensional space is a problem. Then that's why we need like latent space. And here it's just for you to important to follow that all of the new releases are a logical next step of the previous releases. So for this, to compress this, instead of using like standard variational autoencoder, as previously, they trained a separate compression network. As well, they have a space-time patches for transformer tokens. So they have different types of tokens that is needed to understand the actually space-time understanding of the video. And to give you as an example of it, I imagine the video, for example, me, and where this space-time patch is critical. For example, if there is some object moving between me and the camera, and all of the previous networks, they will fail. So for example, if I cover myself with my hand, for example, and after that I become visible in the real world, all of previous methods failed to do this because they didn't understand this space-time feature. But because of this feature in Sora, when I move my hand, it will be able to preserve me on exactly the same space while generating like a high-quality video. They also used some recaptioner from DALL-E 3. Recaptioner is needed to collect actually a data set, because actually the real problem with all of those visual generative AI models is the data set. With data set, you need images, videos, and you need a description for them. So they use different captioners like clip, bleep, or something like this. And there was a specific version of multi-stages captioner presented in DALL-E 3, and they use it. And yeah, and some other like key features that it's like 3D consistent, long range, but still I cannot claim here anything because it's not released. I haven't tested it yet, and we don't know all of the details, and probably won't know or will know in a few years. 3D object generation. The idea is that Stable Diffusion as well can be used for this, and it opens a great potential for marketing, for game dev industry, for virtual try-ons, and for any other use cases. The first idea is to generate consistent multi-view images. For example, this image is generated by myself, something strange, just to highlight that it's generated content, probably a character for some RPG, with 4 frames from different angles, or with 8 frames, 16 frames. It's like character sheet in game dev. You can apply NERF, neural radiance fields. It's the idea to get a 3D object from multi-view images. So it's possible. And as I mentioned, with the power of video generation and 360 video generation, we'll be able to get those 3D results. Right now, as you can see, they're still not the best quality looking one, but with the Sora, and there were some experiments, it can be done in a pretty good way. And here was some example of some of the projects to generate some shoe from for the virtual try-on use case. Very uncommon case is anomaly detection. The idea of those networks like Stable Diffusion and others is that they were trained on a lot of data, and they learned a lot of like spatial features. They know how the normal object should look like. And with this, we can use it, for example, to detect anomalies on the object. Anomaly detection is probably the most useful use case in manufacturing industry or in construction, for example, to detect some scratches like on PCB boards, or in concrete or something like this. And Stable Diffusion can work with this. Just remember about this. It's not very common use case. Changing weather data those are actually images from my master thesis. We were training self-driving cars and applications for them. And the problem is that the majority of the footage is made in like some in US, in California with sunny weather, but in real world you need a different data set from different conditions in order to work properly, for example, in Europe or in UK or in Ukraine or something like this. So that we were using Stable Diffusion and training it specifically to generate, for example, a rainy image. It's exactly the same structure, exactly the same shape, but different weather condition, or like winter with heavy snow, something like this. As well, very interesting. It's probably more research-like project, but as well for self-driving, it's very important to save money on collecting data sets. Here, very like this use case, I can call it low-hanging fruit. Product placement, product environment. For example, if you're selling something on marketplaces and you have some images, or even you took a picture of something with your phone, you can firstly remove background and then place it in a nice looking modern kitchen or wherever you want. This is actually the image from AWS use case, but I did like a lot of similar projects. Another great idea, I mentioned that I will talk about like complex pipelines, not just using Stable Diffusion. So what's the problem with such approaches? So still a lot of companies are using this. There are a lot of money in this direction. But for example, if you want to place, for example, transparent bottle, with transparency, Stable Diffusion and a lot of generative models, they're not that perfect. They can hallucinate a lot and generate some random stuff, and you cannot achieve a rendering quality. That's why what we can do, we can just generate a background for kitchen or something like this. And for example, if we are placing a bottle of water here, we can place a real 3D object, and we can combine our Stable Diffusion with some NVIDIA tools or with like Blender tools, for example, Omniverse or some other tools that support rendering engines. And we can actually create not a generated image, but partially generated and partially rendered image with all of real physics-inspired reflections, shadings, etc. It will look more realistic. And actually, if client has more money and they want to achieve like the realistic view as if it was made by a professional photographer, they will probably need to apply Stable Diffusion, like generation plus rendering. But for the like mainstream components, for example, for e-commerce stores or something like this, just Stable Diffusion, this generation is enough. Product design variation, as well for the marketing use cases, to do A/B testing. For example, my wife prefers more light backgrounds. I prefer darker backgrounds, and probably the success rate for me clicking on this image will be higher than clicking on this. And as well, you can change colors of products, etc. Content localization is an important case. Here is just the image from one research paper that transfers like male body to the female body and back and forth. But why it's important and where is the business use case? For example, you are a retail company, and for example, let's imagine you're advertising the phone, and you have the image of a nice model looking on the phone and presenting it to the audience. And I'm a white male, and this can be done, for example, for European market. But for example, in Middle East, you want to localize this content. For example, if it was a woman, a female, model, you want to generate hijab for her, or to change a tone of skin, or do some other manipulations just to make the content specific for some local needs or local culture, etc. And guys, if you have any ideas or any thoughts, not even questions, like, feel free to write anything you want in the chat. It will be useful for everyone. Now let's talk about some pros and cons for Stable Diffusion. Now we are talking about Stable Diffusion and up to Stable Diffusion XL. The first one is it can generate high quality samples. It's great. User control, style, shape, control net, it's great. Flexibility to data type. If it's medical domain or manufacturing, it's great. And transfer learning, it can be applied and fine-tuned to different tasks for anomaly detection or some others. But still, there are a lot of drawbacks. Computational, expensive. For example, if you're like some startup, you want to train it, you need like hundreds, thousands of dollars, or even millions to train some good quality models. And even for inference, it's still expensive. Training complexity, data dependency, that's a very hard topic because of all the regulations, AI Act, and IP compliance, etc. Interpretability, to understand why the model is generated. And interpretability is connected to actually IP compliance. I will give you as well a fun fact. For example, in Paris, the image of Eiffel Tower is in public domain. You can use it, you can repost it, use that image as you want. But the lighting on Eiffel Tower is intellectual property, and it is protected by the law. You cannot just take a photo of Eiffel Tower at night and then I know, like, print it on some nice paper and sell it. It will be the violation of the regulation and IP compliance. And that's a problem with to understand all of those data dependencies and how it's connected with interpretability. You know, when we are training the model on the images of Paris, the majority of them are actually contain Eiffel Tower. So the model will learn that Paris almost equals to Eiffel Tower. And we did some experiments within my team to have this mapping between the prompt word to the generated image region. For example, if you like type cat running in the field, when you click on the word cat, it will segment cat from the image. If you click on field, it will segment field from the image. So we did this experiment for Paris. And when we click on word Paris, it actually highlights the Eiffel Tower, and sometimes it can be done at night. And this interpretability can show the potential weaknesses and potential law violations that might affect your business or might affect your acquisition as startup or something like this. As well, data privacy, inference speed, and scalability challenges are as well like an important drawbacks. I will quickly run through the challenges. First one is low resolution generation. I understand, guys, that you're probably aware of Stable Diffusion XL, some other models that can generate 1K content, but ask, if you're from the business, ask your marketing teams what is the preferred resolution for their needs. And for example, or if you're in printing business, ask like what is the good level of DPI should be on the printed content. So we need to generate actually not only 1K images, we need to generate like 4K, 8K, 16K, sometimes like of a very high resolution. Another problem is insufficient nature understanding and hallucination, as it's called. Like here is like a default, like old example of 6 fingers or like a lot of hands. it can be refined. There are a lot of refiners for this to mitigate this issue, but still it resolves only some specific problem, but it cannot resolve all of the problems in the world, and sometimes there are the issues with this. Content consistency. So here is Emma Watson. And if we want to generate some content with her, actually, what inspired me to do this slide, like she's right now a student at Oxford, and I met her during Christmas celebration in one of the chapels. And after that, I'm using her in some of the experiments. So if we want to change, for example, the closing, or if we even like the same prompt, we want the same appearance, but from slightly different angle, it can preserve face, because there are a lot like of those models, like for TikTok, for Insta models, etc. But the consistency of closing and background, still, it's a hard problem. Now I have a question to you. First question, if you're not bored, I will try to touch some probably more interesting parts for you. And the second question, what are your challenges if you faced any?
Not bored.
Thank you. Thank you.
I see some answers in our chat.
Okay, yeah, I see it. So what is the cheapest way to inference? Probably reduce the number of sampling steps. We can use Stable Diffusion Turbo, I will mention it. And we have loss going to infinity. Okay, I'm not sure if it was a serious question, but like there are methods to resolve it. Probably you're doing something wrong. Can't keep the same style for 1,000 of images. Yes, same style is a problem. This consistency, actually, firstly, I proposed not to use DALL-E because it's more or less cartoonish, and it's better to use open source model like Stable Diffusion, because there are a lot of extensions like IP adapters or something like this to keep the same style. And after the meeting, if you reach me, I can provide some links of the tools for specific consistency preserving. Okay, let's move forward. There are still some interesting stuff. Modern topics. In order not to get you bored, I will touch it on high level. So stable cascade. The idea, it's as well a modern network from Stability AI. The idea is that the quality is better than Stable Diffusion XL, and it has a better text generation, while the speed of inference is comparable to Stable Diffusion XL. And as well, as I mentioned, I really like ControlNet. It's easier to fine tune with ControlNet. Just one sec. Okay, not to dive deep into technical details. The idea of this stable cascades that we have, we are utilizing its version, sorry for probably pronouncing it in a wrong way, architecture. It's a 3-stage architecture, and this is the same image presented in the stable cascade paper and this version paper. So we have stage C. We have a sampling process to get the global composition of the image, actually, just to understand the image spatial features, etc. So it's a latent space generator. On stage B, we have a second sampling process to refine the details within the latent space. So actually, the idea is between the Stable Diffusion and Stable Diffusion cascade is that in Stable Diffusion, we have one compressing stage, and here we have like 2 compression stages. So the compression is higher. That's why it's simpler to operate in latent space. And in stage 8, like the final stage before the image generation, we have a variational autoencoder to transform the latent image into a pixel image, actually to decode it. I won't stop to here, but a question as well for some interaction with you. If you know any optimization techniques for neural networks. I see the question about graphs. Let's keep that question to the end. Fine-tuning parameters. I mean, optimization in terms of inference or training time or something like this.
Quantization.
Okay, yeah, that's the answer that I was looking for. Or like the first one is quantization, and another like common answer is distillation. So I will just skip the slide. It's just for a reference of physics. It was supposed to be a meme that like those diffusion, distillation, all of those modern GenAI and AI topics, they just have stolen the names from physics. But let's talk about knowledge distillation. Definition for us, it's actually the simple concept of transferring the knowledge from the larger network to the smaller network. With this, we will achieve a better inference. Because, for example, if you have a data set and you are training a network, sometimes your engineers like just took some random network, like, I don't know, ResNet from the internet, and they started training it on a very simple data set. It achieved the good results, but it's an overhead. Some layers are just not necessary for this task. So the knowledge distillation is the process of transferring knowledge from the large network to a smaller network. It's called student network. Just to do the same task, but with smaller network, it will have less parameters and less inference time. Why we were talking about this? Because that's the idea behind Stable Diffusion XL Turbo, which can achieve almost real-time performance. As you can see, they're like just typing something, and it's immediately changing. It's immediately changing on the generated image. So it's trained to produce the images in one step, sampling steps. You remember I mentioned like DDIM sampler, and when I was talking about noise predictor, so we have a lot of noise predictor steps. This model have only one step of this noise predicting. Why we were mentioning distillation? Because as well we have student and teacher network, and I will skip the technical details here. You will have the slide, I believe, or the recording, so you will be able to check this. But the idea is that it uses knowledge distillation, and instead of having 50 steps and 50 seconds generation, we will generate image with one step for like 1 or 2 seconds, or real time if you have better GPU. And it as well uses a generative adversarial network, similar to student-teacher approach or a generator and discriminator. That's why it's interesting as well. Yeah, it can be done like 100 images with 100 GPUs in parallel. Everything is achievable. Yes, 1 second. Stable Diffusion 3. As well, we don't know all of the details, but the idea is that it has a better performance in handling multiple objects and understanding like spatial features. For example, if I describe, I want like dog on the right and cat on the left, and I want like a red ball on top of the blue cube, and behind them is triangle, like Stable Diffusion XL will fail with it, but Stable Diffusion 3 will work with this. As well, better text understanding. And for technical insights, it's built on diffusion transformers. It's an idea of more scalability of it. There will be different numbers of parameters from 800 million to 8 billion parameters. And on the next slide, we have a more technical description of it. So the previous slide was about their like intro of what the model is about. And this slide is about their paper. And I thought that the paper will be dedicated to Stable Diffusion 3, but actually the main topic described during the whole paper is about rectified flow. So probably we don't have time to dive deep in the details here. You can read the paper. The idea is that we should connect the original data and noise from the noise predictor in a straight line, just to decrease this time of getting between learning noise predictor and as well inferencing it, because it has a better connection and better understanding of the original image and noise dependency. And another step, they included this DAT block and diffusion transformers that I mentioned in the previous slide. And Stable Diffusion 3 is not released yet, or you can access it via API, but it's not open sourced here, but I believe it will be like soon. Image prompt IP adapters, probably a very common use case. There are a lot of people who are trying to make money on generating like some models and creating like Instagram models or something like this. And a lot of people are actually paying for it, but I won't talk about it. But the idea is still important, just to preserve this consistency of face generation. For example, if you want to create an avatar, you want to preserve all of the features. And if you want to create multiple images of the simple of the same model, this is important because, for example, if you're generating marketing materials with one model, for example, you have like a brand face, and you want to generate it in different scenarios with different posts with different products, and that's as well important to keep this consistent face generation. And this can be achieved with image prompt, IP adapter. Let me check comment in the chat. Miss AI contest for such AI model. Okay, I haven't heard about this. That's a nice comment. And there are like instant ID, as well some architectures, but just for you to understand, there is a lot of different networks open sourced just to keep the consistency of face generation. There are problems with bodies, with interior consistency, etc. Every research is directed in the consistent face generation, just as well because there are a lot of use cases in marketing, and as well because a lot of people are creating those AI influencers, etc., etc. I understand that it's a very huge market, and a lot of researchers as well. That's why they are doing this work in this direction. There were some questions before the event, so I will try to respond to them here. First, what to use. I selected like 4 main tools that you can use to generate images and apply different extensions, etc. So the first one is Stable Diffusion Web UI from Automatic 1111. It's an advanced tool. If you've played with it, it's great. Update it every time. Use different extensions. Just extend your knowledge in that direction. Conf UI is similar. It's a completely different user interface. You can create and generate images and create pipelines with node base. So you just put the node of text, node of control, node of this. So it has an intuitive interface. If you're a beginner, please use Focus. Focus, it's like free offline, easy to use analog of Midjourney based on Stable Diffusion. I have installed it. If you will have time, I will show it to you. It generates the results, pretty good results, and with very quickly. It has all of the extensions. It's user friendly because there is no need to set up everything. Everything is set up for you. And SDForge is another like UI tool for visual content generation. It's the idea of it is when you have a very limited computational resources on your laptop, like 8 gigabytes of video memory or even less, use this tool. I see some comments in the chat. No, Midjourney, you can achieve much better results with a complex pipeline of Stable Diffusion better than Midjourney. Focus. Okay, yeah, someone sent it. Now let's talk about Civit AI. It's a great community-driven platform where there are a lot of models, a lot of LoRa's, low-rank adaptations, like a small fine-tuned versions of Stable Diffusion for specific needs. For example, if you want to generate anime characters, or if you want to generate like some monsters, I don't know. And there are a lot of different updates, open source models. Just be clear that they don't often have all of the IP rights. There are a lot of not safe for work content, so be careful with it. And if you're building startup around the model, if you want someone to acquire you during this merger and acquisition, there will be a due diligence process. They will check everything, and there might be problems. And just I forgot to mention, there are a lot of lawsuits against Stability AI. Stability AI is not making money from Stable Diffusion directly, but they trained it on some private data. And for example, Getty Images are suing Stability AI for releasing Stable Diffusion. That's as well a problem. Still, all of the lawsuits are in progress. We don't know what will happen, but that's an important point to consider. Question, what do you use? Have you used those tools? Maybe I missed something. Maybe you know some better tools. Just share with the audience, and maybe it will be as well useful for me for the future. If you use some other tools, just mention them in the chat. Okay, let's proceed. There was a question about what to. Okay, someone is talking about Midjourney Clip Drop. So Midjourney and Clip Drop are the tools for specifically for users. So you're using them as a user just to generate some content, but the whole point of like all of those building pipelines, the whole point of this presentation is actually what you can build, like which tools you can build to sell to some other like users or companies like B2B or B2C. And the idea is that I'm not sure, maybe someone is using ClipDrop or Midjourney for the business needs, but it's much better to use all of those tools that I mentioned. Okay, Kohya says, yeah, I know this, it's specifically for fine tuning. Great, thank you for your comments, guys. What to monitor? So first one is Hugging Face. They have a lot of models. You can check everything. They have a popularity. It's very easy to use. They have a lot of demos. You can use a lot of models as an API. You can use a lot of models from diffusers, or you can just download them. It's extremely easy and great tool for everyone to start with. My favorite tool is Stable Diffusion Art. It's a website. Just Google Stable Diffusion Art. There are a lot of tutorials, a lot of explanations, what's Stable Diffusion, how it works. I even referenced some of their images in my presentation, so that's great. That's a great tool. I recommend to use it. They have a membership as well for $6 or $10. Just use it. And as well as they have free articles. Civit AI, I already mentioned it. Reddit, of course. There are a lot of discussions, a lot of nice tools. If you have any problems, there are people who are solving some similar problems and you can use it. YouTube with a lot, like, let's start from 2-minute papers and let's go to different specific videos from specific bloggers. But what's probably new for you, I'm not sure if you're monitoring this, but I really like NVIDIA's blog posts, NVIDIA's web platforms. There are a lot of models free to use for users on NVIDIA platform. Just monitor their updates because they're doing a lot of stuff and they're using some other stuff to in this direction of visual GenAI. They're doing generations. They have Cosmos 2. It's a visual question answering use case. I didn't mention it today, but it's a very hyped use case right now as well. And the last like 3 companies, let's talk similarly about them: AWS, GCP, and Azure. They as well have some blog posts. They have some APIs like Bedrock on AWS, for example, which contains Stable Diffusion, even in painting or painting extensions. So you can use it as an API. You can build some simple use cases around it. You can sell it as a white label software, something like this. Just check what they have to understand what you can build with it and check their blog posts. I hope this is useful for you. Let's go next. There is a last section. I will quickly go through it, and maybe we will have a slight short discussion. Like in 2022, it's an older statistics that I found. The market was valued in 213 million US dollars. Of course, it's rising because there are a lot of investments, especially when some Altman like looking for investment in the chips, because to train all of the models, GenAI models with text, with video, with image generation, there will be more money in this. There will be more use cases that we will be able to solve that. Then it's very important, the whole GenAI market, and visual GenAI is as well rising. So when LLMs are on the top of their hype, image generation is on the hype for users, but not for the businesses. Right now, it's only like getting to the top. So you should start thinking about this to get some new logos, to get some customers with this, or to build some startups around this. There are two categories of market drivers. The first one is technical, like rapid progress. As I mentioned, like every day there are a lot of new articles published, something new. You don't have time to read all of it. From China, from US, a lot of it. There are a lot of innovations, and with the development of cloud computing, and just check NVIDIA's share prices. Like the whole GenAI, there are like rumors that US economy is dependent on NVIDIA, and but I'm not sure about this, but I'm sure that like GenAI and visual GenAI market is based on like all those GPU computational resources, NVIDIA, and that's a very huge driver. And for business, the demand is increasing for visual content. So you can spend, for example, if you're a marketing company or retail store, you can spend like hundreds, thousands of dollars on the professional photo shoot of the model, or you can generate model in a few seconds for free or for $1 per minute. So it's a huge difference. E-commerce, online shopping as well, like with virtual try-ons and with social media users, NFTs. Not sure if it's still on the hype, but as well, this is a great push for GenAI. And there was just a meme startup of generating like Pepper Frog with Stable Diffusion, and they were selling NFTs, and they received a lot of money from that. We have a question here in the chat. Okay, so as I mentioned, it was for the official statistics for 2022. It's now 2024. I include that statistic and the source for it because right now it's very hard to calculate the market with OpenAI as a key player, but as well some other players. So I didn't find some trusted statistics for it. for the whole market, not for OpenAI. So if you will have some insights about it, feel free to share. And if I was wrong or mistaken, and with all data, sorry for that. I hope I will find better statistics, better insights. Market barriers. There are different market barriers. For me, as I see from the projects, the main ones are privacy and security, AI ethics, and copyright. Even hallucinations and so on, it's not that important. What's the most important thing for the business is this IP compliance, copyright issues, and so on. Because, for example, I'm a huge company. Like, we had a client, I cannot disclose it, but it's like for like top 50 companies in the world. So they want to build their own GenAI model to generate images for marketing content. But the problem is that they can use Stable Diffusion and they can fine-tune it. But the original Stable Diffusion was trained on not appropriate data, on the private data. And because of it, if they will go public, if they will use the generated content for the marketing needs, they can be sued. And it's a very critical issue for them. So right now, a lot of companies are using like Stable Diffusion, but for the internal use only to be safe. For external use only, they need to train it from scratch on their own data. I was doing such a project. It's very hard because it's specific for the company. I know that NVIDIA has this option. They have their Edify. So they are training models, something similar to Stable Diffusion, I believe, but I don't know. They're training it, and it's very expensive, but huge companies can allow to do it. And right now, there is a good time for the stock images marketplaces like Shutterstock, Getty Images, so on, because they have a lot of images and they have a copyrights for them. That's why they had a lot of contracts with Google, with OpenAI, just to provide their images to train visual GenAI models. That's a great time for them, but probably it's the final shot for them to get a lot of money. But this is a very critical issue. Just one. Okay, let's proceed. Market trends as well, customer experience, personalization, and tailored marketing. Because as I've shown with the product variations with a lighter or darker background for the image, in Facebook advertisement or in other platforms, you actually, like, they know a lot of about us and they know our preferences. They can perform A/B testing, and we can generate like 1,000 variants of the same product within seconds with the power of visual GenAI. And with this, increase the success rate of the user clicking on that advertisement and actually buying something. So that's a great thing. And processes optimization as well, as I mentioned about going from professional photo shoot, expensive, to the optimized generation within seconds and very cheap. There are a lot of disruptive innovations, so new versions of the project, like different inspiration, visual content as well. It's better. Even this slide, it intentionally a lot of text. It's not visually pleasable, so we need a visual content, generate some images as a business driver to increase the success rate, and so on. Market needs. So we need a cost-effective solutions. People are trying to still GenAI it's expensive. Even OpenAI, like even ChatGPT calls, still they're expensive. For example, if they are charging like 0.9 cents per call or like per 1,000 tokens or something like this, you need to have your own margin. And with this, if, for example, some huge company includes like a chatbot or as a possibility to generate images for the users, the cost can skyrocket very quickly. So that's still a problem. there is a consistent content, as I mentioned, it's a problem, and the market need it. And the search engine optimization is changing as well, as I mentioned, like 1,000 variations of the same product, and explainability as well. Right now, there is a hype. There are a lot of money, but regulators are starting developing some new laws to understand how it works, what are the potential risks, and with explainability, it may become as well a critical need for the market in order to have something against or protect yourself against regulations and so on.